Now we're going to take time to go back and look at all the different ways that we've factored so far in our class. So if we think way back to the beginning, we started with GCF factoring. Remember, that stands for greatest common factor, and you should always look for a GCF, no matter what type of factoring that we're doing, because sometimes if you take out a GCF, it's going to change the way that we factor that parabola or quadratic or expression or whatever, and sometimes it'll make it a lot easier. So always look for your GCF first. So if I start with this example, my GCF with 3, 12, and 9 is 3. And I'm going to keep it positive because my first term is a positive. Then whenever you look at your variables, you always take the variable with the lowest exponent. So all of these terms have an x, and the smallest x is x to the first power. They all have a y, and my smallest y is y squared. And they all have a z, and the smallest z is z to the first. Then I divide. 3 divided by 3 is 1. X squared divided by x is x. I don't need the 1 out front. You can, but you don't have to put the 1 there. Y cubed divided by y squared is y. And z divided by z is 1. It cancels out. Then negative 12 divided by 3 is negative 4. X's cancel. Y to the 4th divided by y squared is y squared. Z cubed divided by z is z squared. 9 divided by 3 is 3. X squared divided by x is x. Y squared divided by y squared cancels. Z squared divided by z is just z to the first. Remember, whenever you're done, I started with 3 terms, so I have to have 3 terms in my parentheses. And there should be nothing left in common between all 3 terms if you pulled out the correct GCF. And in this case, there's nothing in common between 1, 4, and 3. And they don't all have x's, y's, or z's. Grouping is what we do whenever we have 4 terms. Right? So first look for GCF. They do not all have an n, and 2, 5, 2, and 5 don't have anything in common. So I'm just going to cut it down the middle. So if I cut it down the middle, my GCF of the left side is just n squared. And that leaves me with a 2n plus 5. The GCF of the right side is going to be a negative 1. They don't have anything in common, so it's just going to be a 1. But then because it's a negative in my leading term, it's going to be a negative 1. And all that's going to do is change my sign. So it's going to become positive 2n and positive 5. My parentheses are the same, so that's one of my factors. And then my other factor is going to be n squared minus 1. Now, always pay attention and look to see if you can do anything else to those terms. Now, 2n plus 5, that one's done. I've gotten down to my variable to the first power, and they have nothing in common, so I don't have a GCF to take out. But n squared minus 1 is what we looked at towards the end of factoring, and I have 2 terms, subtraction, and 2 perfect squares. So this is difference of squares. So n squared, square root is n, square root of 1 is 1. So this parentheses can break down farther to be n plus 1 times n minus 1. Now that's not my final answer. I still have this parentheses 2n plus 5 that I can put out front. So this is the complete factored form of this polynomial that we started with. Always look to see if you can keep going. Then we looked at trinomials, where we call them plain Jane trinomials, where a is 1. So even though we have a's in here, the coefficient out front is a 1. So all I have to do is find numbers that multiply to c and add to b. So in this case, I want to multiply to a negative 6, but add to a positive 1. Now remember, to multiply to a negative, I have to have one positive and one negative. So I could have 1 and negative 6, or negative 1 and positive 6. I could have 2 and negative 3, or negative 2 and positive 3. And then my next one would be 3. So once I start repeating, I've found all of my factors. 1 and negative 6 gives you negative 5. Negative 1 and 6 is positive 5. 2 and negative 3 is negative 1. And negative 2 and 3 is positive 1. I want to add to a positive 1, so my factors are going to be negative 2 and positive 3. Then I'm going to fill in with my a's first, and then just put in my factors. So I have a negative 2 and a positive 3. Remember, the order of your parentheses doesn't matter. This is the same thing as if I were to put the 3 first, so a plus 3 and a minus 2. That order doesn't matter. Then we looked at trinomials where a was something other than 1. And for this, we had 2 different options. You don't have to be able to do both. Just pick one and get really good at it and do it every single time. So the first one we have is bottoms up. Okay, still look for your GCF. Sometimes if I take out a GCF, I no longer have an a that is other than 1. It'll be a 1, and I can factor like a plain Jane trinomial. But in this case, between 6, 11, and 13, or 3, sorry, I don't have a GCF, so I'm going to have to do bottoms up. So I'm going to rewrite it over here. And my first step is going to be to temporarily get rid of this a. So I'm going to take it and make it part of c. Then I'm going to rewrite it with an a of 1, and that's going to make it x squared plus 11x plus 18. Then I've got to find numbers that multiply to a positive 18, but add to 11. Now, because I have all positives, all of my factors are going to be positive. So we have 1 and 18, 2 and 9, 3 and 6, and then 4, 5 doesn't go in, so then I'm back at 6 and 3. So once you get to where you repeat, you have all of your factors. So I've got 1 and 18, which gives me 19, 2 and 9, which gives you 11, and 3 and 6 gives you 9. I want 11, so my factors are 2 and 9. So I'm going to put my parentheses. I'm going to have a positive 2 and then a positive 9. Now remember, I temporarily moved my a to make it part of c, so now I've got to take it back out by dividing. I'm going to divide both of these by 6 and simplify my fractions. So 2 over 6 simplifies to 1/3. And 9 over 6 simplifies to 3/2. Oops, that should be a plus. We can't have any fractions, so this is where we go bottoms up. So then we have 3x plus 1 and 2x plus 3. Our other option is reverse box. So I'm just going to rewrite it again. And remember, your first step for reverse box is similar to bottoms up. We're going to multiply a and c. So I'm going to have 6 times 3, and that equals 18. We're going to have that off to the side to come back to later. I'm going to draw my box, 2 by 2, and I can put the first term in the top left corner and the last term in the bottom right every single time. Those are always going to end up there. Now I'm going to fill in these 2 boxes. I'm going to find 2 numbers that multiply to this 18 but add to 11, to the b term, which we already found whenever we did bottoms up to be 2 and 9. So I'm going to put my 2 and 9 in there. Now remember, whenever you multiply with a box, you always end up with variables in these 2. So you're going to have to add in your x's. Then we work from the bottom corner out. Find the GCF. So the GCF with 9x and 3 is 3. 6x squared and 2x is 2x. 6x squared and 9x is 3x. And then 2x and 3 don't have anything in common, so that's just a 1. And now these are my factors, so I have 2x plus 3 and a 3x plus 1. Remember, when reverse box, whatever the sign is on the outside is the sign that it keeps. All of these are positive, so all of my terms up here are positive. And then the last thing we looked at was difference of squares. Okay, so remember, it's got to be subtraction. That's what difference means. And then squares is talking about the perfect squares. So the numbers would be like 25, 36, 49. And then for variables, it's whatever has an even exponent. That's how you know it's a perfect square for a variable. Again, look for a GCF first. So if I look at 3 and 48, they both have a 3 in them. So if I take out a 3, then they have x and y, so I can't take out a variable. If I take out 3, that leaves me with x to the 4th minus 16y to the 4th. I have subtraction and I have perfect squares. The square root of x to the 4th is x squared, and the square root of 16y to the 4th is 4y squared. Just cut your exponents in half. So then I'm going to plug it into the pattern. So I've got my 3 on the outside. It's still part of my answer. And then x squared plus 4y squared and x squared minus 4y squared. Again, always look to see if you can keep going. For addition, we don't have a pattern, so I can't break this one down anymore, but let's look at the subtraction one. Right, I've got 2 terms, subtraction, even exponent, and 4 is a perfect square, so I can break it down again. The square root of x squared is x, and the square root of 4y squared is 2y. So now I'm going to bring this with me, the 3 and the x squared plus 4y squared. That's still part of my answer. But now, instead of writing x squared minus 4y squared, I'm going to apply the rule again. So I have x plus 2y and x minus 2y. Always look to see if you can keep going. The last thing I want to mention in this video is going back and using the calculator. Sometimes if you have really big numbers, it's kind of hard to figure out all the factors without missing any. So for example, if I wanted to find the factors, let's go back to this one. I want to find the factors of 18. It wasn't so bad to write it out, but if I go to the calculator, go to y equals, take whatever number you want to find the factors for, divided by x. So I want to find the factors of 18, so I'm going to do 18 divided by x. Then I'm going to go second graph to get to this table. You're always going to have an error for 0 because we can't divide by 0, but then after that you start listing your factors. We only want integers, no decimals or fractions or anything. So 1 and 18, 2 and 9, 3 and 6, 4 is not a factor because it's 4.5. And then if you keep scrolling down, eventually you're going to get to where they repeat. So we had 3 and 6, and then we went to 6 and 3, so that means that my factors stop with these 3. Okay, sometimes for bigger numbers you need a little help, so you just go to your calculator, y equals whatever number you're looking for divided by x. Look at your table, and there's your list of your factors.